Have you look at the camera this time and go ahead and introduce yourself, first and last name, the school we're at today, and the grade you taught.
My name is Issa. I'm a math teacher, grades 9 through 12 at Bethel High School. The class I taught today is Math for College Prep. It's for seniors who did not pass Algebra 2 or did not do well in Algebra 2 and are not ready for advanced math upper level classes.
Good. So I just hit record. We want to understand the decisions you made in planning for this lesson and how it fits into the unit and year. How does this lesson connect to and build on How does this lesson connect to and build on students' prior skills and knowledge? What was taught before this lesson and what will come after it?
The students are required to learn about linear functions, quadratic functions, cubic functions, and other polynomials, exponential functions as well. In this unit, we, cut it out. Cut it out this one. Yeah, because I need, listen, I'm going to put the question away from me, and it's not just, this is,
okay.
This is fine.
Okay, so when you're ready, go ahead.
The students have been working on an online program to develop their basic algebraic skills, and they are at different paces. It is a self-paced program, not competitive, and all what it focuses on is on basic math skills. With this activity, I'm trying to engage the students in real-world applications, encourage them to interact with each other, and get them ready for the college math placement tests. So what we've been working on is projects, different projects over the past semester, focusing on distance formula, focusing on using both linear functions and quadratic functions as well. So prior to today's lesson, we introduced quadratic functions. We graphed quadratic functions. We created scatter plots and identified data sets, whether they can be modeled as linear functions or as quadratic functions. In today's lesson, the students are ready to analyze the function as a and analyze its graph as a continuous function, as a continuous graph.
Okay. What was taught before this lesson and what will come after it?
The students learned how to identify the domain and what it means in a real-world application, how to identify the range, and also what it means in this context. How the graph behaves over time, that is the value of y increasing as a function of x, or is the value of y decreasing as a function of x? We touched bases on x-intercepts, on evaluating functions, and behavior of functions.
Okay. Talk about the standards or cluster targeted in the lesson. What did you do to make the lesson reflect the full intent of that standard or cluster?
I focused on two standards. One of them is representing and solving equations and inequalities graphically, and the other one was interpreting functions that arise in applications in terms of context. Instead of asking questions using abstract terms, I used the real-world application to state my questions and focus my questions on that real-world application. And then I connected it to the technical terms and the vocab terms that we use in math.
Which of the core action indicators do you think this lesson best exemplified, and how do you plan for this?
I focused on conceptual understanding of math terms in a real-world application. And instead of introducing or defining the term from the very beginning and then doing the application, we did the application, made sure that the students understand what's involved in there, what the variables are, what relationship there is between the independent variable and the dependent variable, and then introduce the concept. So the students would think about the words, do they make sense in that context? And what does it mean to have different values for X and different values for Y in the relationship between the two?
We're interested in how the shifts required by the CCSS are being incorporated into your classroom. Discuss how this lesson illustrates the shifts required by the CCSS.
Well, this lesson illustrates particularly Common Core Action 1, ensuring the work of the lesson reflects the shifts, which are focus, coherence, and rigor as required by Common Core state standards for mathematics. In terms of focus, the lesson focuses on the clusters as well as the standards related to functions, to making relationship between variables, and also use these functions for predicting values of distance in terms of the time. The lesson also reflects coherence, where the students relate new concepts to their prior algebra skills and knowledge. They know that there is a relationship between the independent variable and the dependent variable, and the knowledge was somehow passive. I see them more connecting distance and time in this real-world application. And it was easier for them to understand the regression function and easier to understand the relationship between the zeros of the function and the x-intercepts, you know, the different relationship between the variables. In terms of rigor, the focus of the lesson was conceptual understanding of the math terms. The process was important. For example, when they were evaluating the distance function for a given value of time, it was important that they use quality work. They show the process, they show f of x, and show the work, and then find the answer, use units at the end, and explain the relationship between x and y. In terms of application, the whole lesson was application. It was all related to a real-world application. And basically talking about the numbers, talking about the results, talking about the variables and the function, and connecting everything to the graph and the table that they were using made it easier for them to understand the relationship or the connection between math and real world. And at the same time made it easier for them to use the correct terms, vocab, math terms, and to have a better understanding of the math concept.
How did you teach the content of this lesson prior to the CCSS? What is the same and what's different?
For this specific class, we used in the past an online math program where the student can practice math problems, get help online, do the work, self-paced, non-competitive, but there was no interaction. And I realized that with the Common Core, the student will have better understanding by being engaged in the lesson, interact with other students, talk about math terms, show the work, explain it to other students. So this year, I'm teaching this course using project-based learning and blending it with technology, with the online program, instead of just focusing on the online math program.
Student engagement is crucial to the work of the CCSS. We want to understand how you ensured that all students had the opportunity to productively engage in the work of the lesson. Did the students understand the mathematics of this lesson, and how do you know?
I introduce the objective at the beginning of the period, so it's very important they know what we're focusing on. I engage them by asking questions to identify concepts they're familiar with and concepts that they are not familiar with, so I know where to start with my lesson. During the lesson, I ask students questions, so there is always ongoing interaction between me and the students. Even if it's a new concept, I try to find out what the student understands before, or what the student knows before I go on with introducing the concept or the process. Once the concept is modeled, I model the concept or the process. I guide the students to practice a problem with me, at least one problem, and then I let them do some work in groups where they can ask each other and they can ask me. I keep walking around and checking, finding out which student or which group needs help.
I'm going to have you hold the paper still, because every time it makes noise in the mics. Okay.
So,
Next question.
I don't need this because this is completed after the lesson.
That part?
Yes.
Okay. Explain how you differentiated in this lesson. Did all students have the opportunity to work on grade level content?
Yes, all students had the opportunity to work on grade level content. Some students were ahead of other students, so they answered more questions than other students, but some of the questions were repetitive in a way, because I anticipated that some students are going to be ahead. For example, one of the questions I modeled where I showed them where we might have 2 points with the same y value, and then I asked them questions, and then I asked students to find points on their own where these points share the same y values. So the students who were ahead answered all the questions and got to the summary at the end of the activity. And some students who did not get through all these questions, I prompted them to answer the last question where they summarized their findings.
Which behaviors from core action 3 did the students best exemplify in this lesson, and what actions have you taken as a teacher to make that happen?
Action 3, teacher does, student and teacher. Will you repeat the question?
Which behaviors from core action 3 did the students best exemplify in this lesson, and what actions have you taken to make that happen?
The students were able to discuss questions when the question was not clear to them. Some of them preferred to work independently, so I approached them and I asked them the question, or I prompted them with other questions so that they can get engaged. Couple times in the lesson, like a student would answer a question and then I ask another student to restate the question. In the activity itself, at the end where the students summarize their findings, I ask the students to share their findings, provide feedback to each other, and add in sentences, in writing, what they learned from each other. I also prompted the students to show work on the board or to explain their work, either verbally in writing or by presenting it to the class.
Would you like to comment on any of the submitted students' work?
After I
They haven't submitted it.
Yeah, I have the work,
Okay.
but I haven't looked at it. But roughly speaking, when I was walking around and I was checking students' work, the slower students like skipped few questions. The students who are ahead of everybody else, they answered more questions before they summarized their findings. But overall, all the students were engaged in the lesson and all the students were showing work in their packets, but different paces.
Great instructors are continuously learning. We want to understand what you celebrated in this lesson and what you would improve upon. Reflecting on the lesson, what worked particularly well and what might you do differently?
Worked well, what I would do differently. I didn't get through all the questions in the lesson. I would probably add a higher order critical thinking question at the end for those students who are more advanced than the other students, instead of having the same question or similar questions repeated to ensure that they know the content. I was satisfied with the grouping of the students and with the discussion that went on with some groups. The groups who were not really engaged or doing the work or discussing the work were the students who really needed the help, and these were the students who I attended to most of the time because they would read and do not understand what the question is asking them or what they're supposed to do.
Were there any surprises or unexpected student behaviors or reactions?
Couple students leaving early before the end of the period because of medical issue, and another one because of an appointment with a college representative.
That's it. You're done.
Thank you. Thank you.
you.